All right, now, as before, I'm going to create a new layer. I'm going to get rid of the asteroid layer that we've been playing around with and close down its map since it no longer connects to anything. I'll hit the F key to focus just on this layer for a moment. And we'll need to fill this with white, which is now our foreground color. So I'll hold the Option key down and hit Delete. That would be Alt on Windows. And this time we're going to start with a cylinder. So let's go back up to the 3D menu. Under New Mesh from Grayscale, choose Cylinder. With the expected results, we get a nice smooth cylinder. And if we use our 3D Rotate tool, we can pull it towards us and see that it's a hollow cylinder. This will come in useful for us as we make our goblet. But at this stage in the game, I'm going to recommend against using the object manipulation tools any more than you have to. And the reason for that is it's pretty easy to end up with objects that are at a very strange orientation, and you kind of forget what the original setup is like, particularly when you start messing around with object orientation and combine that with camera orientation. And then later on, as you start assembling more complex objects, it gets very difficult to line them up because each one of them is going to be generated with default coordinate settings. And so moving the objects around any more than you have to, in general, when you're building more complex stuff, is not recommended. So let me undo that move. And instead, if we need to move around, the camera tools are a little bit better for that purpose. We can still click and drag, and you'll notice that they behave in the opposite direction from the object tools. And in terms of the object tools, it's as if you're dragging the object. But when you're actually clicking and dragging the camera tools, the results look as if it's working in the opposite direction. But if you think in terms of moving the camera instead of moving the view, it'll kind of make sense to you. But I'm going to turn this just so that we can barely see a view into the top. And now if we open up the cylinder's depth map, come back up and choose the 2-up view, I'm going to now apply a linear gradient to my depth map. And by doing so, we're going to learn a few things about how Photoshop works that may actually be a little bit surprising. We've got white as a foreground color, black as a background color. Let's go completely default with this and use the default gradient, foreground to background, the basic gradient that is the basis of all other gradients, and make sure that the first gradient option, the simple linear gradient, is chosen. And we're going to come over here, and as close as we can, we're going to try to click on the topmost pixel, hold the Shift key down to constrain this to perfectly vertical, and try to release this as close as possible to the bottommost pixel to generate what should be a perfect gradient from the topmost pixel to the bottommost pixel of our altitude map. And the end results will be mapped to the geometry of our object. If you look at the results, you can kind of see what happened. And it's sort of what you might expect based on what you've learned about altitude maps, which is that the brightest pixels, which are down here, represent the highest altitude from center for our cylinder, and the darkest pixels, the ones up here at the top, represent the lowest, which is what you see here, and we end up with this kind of a cone shape. But it's not really a cone. It's got this tapered slope to the side. And there's a bunch of noise in here too. It's actually very bumpy. And we can come over here and we can reduce the height of our cone a little bit so that it's more like a Hershey's Kiss. And the curved sides that we're seeing here are evidence of an interesting thing that happens inside of Photoshop gradients, which is that in order for gradients to be perceived as a linear gradient, they're actually mathematically being rendered a little bit different. And if we highlight our gradient layer and go back to our gradient tool, let's look at the gradient settings for any clues that might help us out here. And the main one is right here. There's this smoothness setting that's set to 100% by default. And what this essentially does is it applies a gentle Gaussian distribution curve to our gradient so that the white takes a little bit longer to start scooching down to gray and then steeply slides down into black where the black kind of smooths off at the end. So basically it's a curve that's applied to the distribution of pixels. That's the end result of this smoothness setting. But for our modeling purposes, we're going to want to crank this down. Now remember you've done this, because later on you want to make sure if you're actually drawing a gradient that you want to look its prettiest, the smoothness setting probably does want to be set back higher. But when you're doing gradient work in 3D, you'll probably find it useful to set this value down to 0. Click OK. And once again, we're going to apply the same gradient and observe the results. Click, hold the Shift key down, drag, let go. You can already see just a tiny shift in the grayscale when I let go that indicates the difference in how these two gradients are being drawn. And when we go back, we're going to be a little closer to our goal. And sure enough, the majority of the curve has disappeared, particularly towards the lighter end of the spectrum. However, as we get up towards the blacks in our grayscale source, there's still a little bit of a curve in this cone. What the heck is going on there? Well, I'll tell you, it took me a long time to figure this out. But if you come over to our grayscale map that we generated using 3D new mesh from Grayscale, and we examine the grayness of our map, look up here at the top, it's not gray, it's RGB. The brightness levels of these pixels are being passed through to create our sort of cone shape, but they're actually being interpreted as a full color image that somehow is being color managed by Photoshop to produce this gentle curve. Probably something to do with the gamma display settings, and they may differ from machine to machine. The way to solve this, and this starts to reveal just how much you can play around with these source layers, is to come over, make sure this layer is selected, go up to Image, choose Mode, Grayscale. Discard the color information. Nothing changes on screen, but watch the difference when we draw our new gradient. Once again, the distribution is visibly different, and when we come back over and let the mesh redraw itself, boingo. We have a straight line distribution from the top to the bottom, and this is the closest that we can get with a mesh to an actual cone with a perfect linear distribution of pixel values from black to white. Now there's still one niggling question about our image, and that is, why is it so noisy? If I zoom in here a little bit, you can see that the surface texture that's being generated by our presumably smooth grayscale gradient is actually resulting in a kind of chunky result. You can really see it as we start to move the camera around and it interacts with the light. I mean, look at that. And the specular highlight here, you can just see a tremendous amount of noise. And what's going on actually is a result of one other aspect of our gradient source layer, and that is it's 8-bit. So even though we've generated a linear gradient from top to bottom, we got rid of the smoothness, we got rid of the color information so that we were only working with pure shades of gray, the truth is, at 640 pixels tall, there are only 256 shades of gray to distribute among those pixels. So we might have 2 or 3 lines the same color before it shifts to the next and the next and the next and the next. And those little lines are resulting in the artifacts that you see here. The way to solve that, once again, is to investigate the mode of this source image. If we come back up here to Image, choose Mode, and instead of using 8 bits per channel, we want to give ourselves more shades of gray to work with. And to do that, we need to up the bit depth of this source layer. We're going to switch it to 16 bits. And one more time, we're going to draw the gradient, which will now not distribute 256 shades of gray, but we'll pick 640 shades of gray to represent the 640 lines from top to bottom. You won't see much of a visual difference on screen, but now when we shift back and look again, once again, at our cone, you're going to see 2 things that are quite different. One is it got a whole heck of a lot bigger, and that just has to do with how the math is converted from values into actual geometry. We're now working with a lot more numbers, and so we're starting at a value of 0, but we're ending up now at a value in the thousands, and that's being reflected in our model. So you want to make a shift like this as early as possible in your workflow so that you can compensate for it. And in our case, the compensation means we'll come back to our object tools, just reach out over the widget and grab the overall scale button, click and drag until the size of the base is about what it was before. Then hover over, and we may have to make this a little bit larger in order to see it clearly. Hover over the scaling square for the blue axis and click and drag it up. That will return our vertical scale so that our cone's appearance is approximately what it was before. If we grab our camera rotation tools again, rotate this around, you'll see nice, smooth specular highlight where before we had an incredibly bumpy one.